Yes, Dr. Tushar.
Yes, sir.
So is that do we have M. Sangeeta madam with us?
Yes, yes, I'm on call.
Okay, so shall we start? Should I start?
Sure. Yes, sir. Yes,
Okay,
sir.
okay. So yeah, myself Gulab Pamnani. Welcome to all the participants on behalf of MNIT. So this workshop has been organized in association with Arc Info Solutions, and uh, we have the resource person M. Sangeeta from Arc Info Solutions who will be taking us through this workshop. So I welcome M. Sangeeta on this workshop, and as you as all the participants might be knowing, the conventional in the we nowadays we don't do the traditional way of designing. Nowadays we don't build the prototypes and go for the testing. Rather than we what we do, we do the simulations through the software like Ansys, and Ansys is one of the widely used software in the industries for simulation purpose. So thus we have organized this workshop. We have Ansys in our MNIT, and I'm sure that this workshop will help our participants to learn more about the simulation techniques, and they would be having the hands-on on Ansys workshop on the Ansys software. So they would be able to analyze the uh, structure, and in maybe in the upcoming modules, whenever we'll have the workshop on the CFD part also, they will be able to do it. So this workshop will surely help our students and our participants to do this simulation using Ansys. So over to you, M. Sangeeta.
Thank you, Gulab
Thank you,
sir.
sir.
Uh, Sangeeta, just I will take a few minutes to describe and set an agenda what we are going to do in these 5 days. Thank you, Gulab sir, for introducing to all the participants what is being all about simulation and why it is being used. And As you have correctly said, that ANSYS is a widely used tool in industry. So the the best way of getting a placement right now for a student is to get trained in in a software or a tool which is being used by the industry itself. So by the time you will be graduated, by the time you will be post graduated, you will be ready with the tool so that industry can groom you itself. So that is a one point, and another point is that we will be giving you the glimpse of ANSYS structural module in these 5 days. Initially, we planned for a mechanical and CFD workshop together, but as per the guidance from the faculties from Manage Jaipur, we planned it to do 5 days for mechanical ones, and then we will be planning it CFD for a separate one, so that the entire 5 days will be dedicated to one particular physics. So we do have along with us Sangeeta, and also the few of the session will be taken by Sneha. She will be taking care from Monday, but to Saturday, Sunday, Sangeeta will be engaging with all of us. Basically, our main aim is to give you the glimpse of mechanical structure here, how to design your model in Ansys, then what are the different meshing techniques you can be use for solving the problem. The majority of you will have a problem if you have already used Ansys, that the meshing is a major problem creating issues in simulation. So we will be providing you the detailed information about the meshing, which particular meshing is been required on what type of geometries, how you can change the mesh size, how you can utilize local mesh and global mesh things for your geometry parts. Then we will be letting you know how to set up a complete problem in Ansys, different loading and the boundary conditions part. Then the contacts, which is very important these days, whenever there are two bodies, how they will interact with each other, how the load will transfer through contact part. So we will be letting you giving you the knowledge about it. And lastly, we will be doing a non-linear problem also. So these 5 complete days will give you the glimpse how to solve the basic to advanced level problem, which will help you in solving your major projects, or your uh, if you are having a student from MTech and PhD's part, how these tools will be helpful for writing out your thesis work. So this is all about Ansys. And even this complete 3 hour sessions we have divided into two segments. The first 1.5 hour will be dedicated to the solver itself, means our trainer will train you in 1.5 hour. They will tell you how to set up a problem, how to solve it, and later 1.5 hour we have kept it for a hands-on part. So already I have shared the mail and faculties have shared the mail to you related to NSYS student version, how to download it, how to install it. All the guidelines have been already shared with the participant. So I request all of you to please install it. If you have not installed it by now, backend you can install it, so that what all things we are providing you in 1.5 hour initially, you can practice it there itself in another half. And if you have any doubt, you can directly ask through a expert. So it will be a doubt clearing session itself. So that is our plan. So I hope you will utilize this 5 days at max, and you learn a lot about Ansys. So this is our thought process for organizing this 5 day training. So over to you, Sangeeta. You can please proceed with the session. Thank you
Yeah.
very much.
Thank you, Tushar, for letting know students what is the importance of the sessions and what all are going to be covered. And thank you, Gulab sir, for elaborating the importance of using a simulation tool. Okay, so apart from this, so we'll first initially start with the modeling part, not much in depth, but yes, which will make you understand the use of modeling. And if you have prior modeling knowledge, then it will be an add-on advantage. And if you are new to it, then still you will get some glimpse of working with the tool. So this tool is not like something you haven't seen any not much difference in the GUI you'll find. So it is very similar to any other CAD tool that you have used. Okay, so let me first share upon my screen, and then we will start with first. Okay, so we'll start with launching a space claim, getting over the workflow process, how exactly space claim can be
Yeah,
used, and what are the different
sorry to,
features that are we going to utilize it.
yeah,
Uh,
Sangeeta.
is someone speaking?
Yeah, Sangeeta, this is Gulab here.
Yeah,
Uh, yeah, sorry to interrupt
yes,
in.
sir.
Have you started the recording?
Uh, I'll get started.
Yeah, just start the recording of the sessions.
And Sangeeta, if you can change the settings so that the participant can be allowed directly by bypassing the
It's
Yeah.
already said that they can join directly.
Okay, okay, okay.
Okay.
Otherwise, it will
It's
be
already said.
popping up the invitation every time.
Yeah, yeah, that thing is already done. Don't worry about
Okay,
it.
Okay, okay. Thank you,
fine.
thank you.
Thank you. Thank you.
Okay. Yeah. So let us just understand where all one person can use the space claim. So there are so many applications where you can try and use your space claim. You know that in the student version you have a bit of limitation, but if you get started, then when you have your like tool in your campus, that time you can explore more. Or if you are working with the student version itself, to initially get started, you have limitation for using a limited number of components, but you don't have limitation that you cannot use certain tools or something. So it's always better with the student version, whatever workflow we are carrying out, that if you practice, it will be really good in case of you working for any of your projects. Okay, so first let us understand where this space claim can be an add-on advantage for us. Let first advantage is 2D and 3D modeling you can do, sketching and modeling part. Then next you can also work on your assembly part, or you can if someone is working on designing aerofoil or something. So those kind of naka points will be there, right? So those you can import those as an input file, and you can import create your geometry as well using some coordinate points. Then to measure an existing geometry, modify. So whenever you're working, like if you want to just make simple modification, you don't have to get into the sketching zone once again and change it. It's like rapid changes whenever you're working. If you pick out a surface, if you want to drag and give certain changes in it, you can do it. Then next you have working with the STL file. So using facets tab, you can work on your different STL files. When you import those geometries, you can basically work on clear making them have a smoothened part. Or if you want to I mean to say, like in case you want to have a better you whenever you are importing some STL files out of simulation done, like let's consider you're working on a topology optimization. So there first you'll perform structural analysis, then you will get the zero stress concentrated region, and that STL file you'll take it for design optimization, and you will take it into space claim, and you have to give some smoothing to that geometry, right? So their facets you can use it to work on it. And also you can work on additive related problems. Either you have to create the support or orientation. If you have to modify, in that case additive tab can help you out. The most important thing that we consider in terms of working on a simulation is where you design geometry on different platforms. That could be any CAD tool, you can say. It can be SolidWorks, Creo, CATIA, anything. But when you are trying to import it for simulation, there is a GUI change with which you get to see lot of differences in your geometry, and which will not make you have a proper geometry. Let it say your geometry get converted into 2D, or in case of when initially it was 3D, and when you are importing here, due to some data loss, it is getting converted into a surface body. So those problems have to be rectified, and you have to modify them and get the actual geometry. In that case, your repair and prepare tab will play an important role. And let's say someone is working on some beams problem. So related to beams, there are certain standard libraries existing, out of which you can take those cross sections directly and you can use it, or you can also extract from the existing 3D models. And you need not worry about connecting those beam models, because directly you have a beam connectivity which will help you in terms of having a continuity and the load transfer, what we talk about in terms of beam. So that also you can do it very easily. Then you have direct option to work with contacts, I could say, like wherever you have to assign the bonded kind of connectivity. So if someone is having an idea about contacts, then they will understand that using share and unshare option, you can directly bonded contacts assign in the space claim itself. So when you're taking this geometry to your simulation window, you don't have to work with defining bonded contacts. So that is one of the add-on advantage. And also you can do one more thing, that is whatever geometry you're working directly, you can take it to the different simulation platforms. Let it be working with the mesh, or working with some kind of fluent window, or working with mechanical. So other than that, you have another new feature coming up with the last 2 3 versions, you can see. you are able to mesh your geometry using SpaceClaim also. So a person who are familiar with workbench meshing, they can proceed with workbench meshing, and people who are interested in knowing, they can also get to learn from SpaceClaim, and they can use it for the simulation. And otherwise, people who work on the Fluent window, of course, they can go for Fluent meshing or workbench meshing or SpaceClaim. So they have options available, whichever it is convenient for them, you can go for it. Details tab is basically used for your design sheets when you make drawing sheets, right? So in that you have to specify your dimensions and in-depth detailing of your drawing you need to mention. So in that case you can use your detail tab. Other than that, you have sheet metal section here, which is quite like people who have worked on sheet metals earlier, they will have an understanding that sheet metals nowadays, it is an very important thing to know. If you don't know the 3D tool modeling, doesn't matter, but if you are working with the sheet metal thing, it's really important, because folding, unfolding, and how much material have to be utilized, all that you are able to work it with the sheet metal, right? So in that case, it is similar to your SolidWorks interface, I can say, in case of working with the sheet metal. So all that, if you certain option like certain applications, I'll tell you, in case of giving a proper bend, or if you have to fold your geometry or unfold of your geometry, right? So in that case, or corner reliefing if you have to do. So in all those conditions, you can work with the sheet metal tool, and this is quite sufficient for working with it. Next you have is your tools, in which one you can work with the manufacturing related applications, where you have a standard holes existing, which you can use it for your geometry directly. And also person who want to work with the reverse engineering, let's suppose you are getting some CT scan or something, right? So out of that you will get the surface modeling. So when you want to make out of that some complete 3D solid geometry, if you have to convert, you need to capture the complete region and you have to work it in a reverse engineering way, right? So in that portion you can make use of this reverse engineering tool. There are certain aligned keywords available based on industry applications. These tabs will be customized. Okay, so other than that, let's focus on how to get started. I hope with this, what are the different applications available in case of working with SpaceClaim, you have got to know. So let's begin. First important thing, whenever you're working with CAD, any designing model, sketch plane have to be, sketch plane is most important, right? So what is your sketching plane? Generally, I would suggest whenever you're trying to work, make it as XY as a sketch plane. So in case people who open first time software, they may or may not be seeing as XY as the sketching plane. So just go to file, you have SpaceClaim options, and out of that you have advanced, and in your advanced section you have a behavior option, right? So in that behavior, just let it change to Z as your top view direction. Okay, and sometimes people would also whenever they are opening software, because of not assigning a proper graphic card, you may face graphic card issues. So in that case, just use your latest version of graphic card here, that will work out. Okay, and just say okay. Or else if you have other settings to carry forward, just let's focus on next. What is the thing that we need to do is to set your units when you're sketching. So you can set this units either to your complete space claim journey, or you can make it limited to your single screen, whatever you're working. So let it be all new documents or this document. So you can change it to either imperial, metric, or in terms of defining length, what is your unit you can define, or for angles you can define. So all these dimensions, whatever you want to want to define the units, you can make from your unit section. Appearance, of course, you can customize your set, and anytime you are losing this like default window, just click on this reset delocking layout. Okay, so these are few new things that you need before getting started. Just you need to have an idea, and then say okay. So all those changes to reflect, you need a fresh screen now, which will have your changes done. So go to new and say design. Okay, so you can have multiple windows in your space claim, and whichever you are not working, just cross it off so that only that particular window you have. Okay, so first let us understand, in case you want to, for, because we are saying you are able to do your cleanup of your geometries when you work with the different CAD models. So go, first we have to know what are the file options that you can open it, right? So there are a set of extensions which you can use to import your geometry. So let it be STL format or SpaceClaim format, SolidWorks, or you're working on some parasolid geometry, anything you wish. You have almost like all the possible extensions are available here. And if you're not sure of going and selecting serving, just make it as all files. So just type the file name and you will be able to open your file. Let's suppose I open this geometry. Okay, so here's my geometry open, right? Similar way, you can also open any other file that you wish to open. And now let's take a fresh screen and we will understand how to work with designing, right? So first thing, let's understand the sketching tab more and try to start with it. So you have here home window, like anywhere your geometry on the screen it's lying, just click on this home, it will come in the center. Okay, then you can plan your view. Can use either from here or you can use it from this quick toolbar, plan view, to set your plane. Then you have different orientations available, left direction, right, or isometric, trigonometric, whatever is the view you want to have, you can have from here. And the first next you have is to create. So in case of creating, let's suppose I start up with my line creation, right? So I can create my line using Cartesian dimensions or polar dimensions. So by default, when you say it will give you a proper dimensions as well, but anytime you wish to have some Cartesian or polar dimensions to be activated, you have in the left side, you can activate and you can use it. Okay, so this is how you need to, for creating a line, you need to define start point, defining the dimension you need, and the end point will be already specified with your dimension, or drag and first point and second point manually you can assign it, right? Then next you have is for circle. So basically you have two types of circle. That is, first you pick out the start point and define the dia, how much it should be, and your circle is ready. And the other one that you have is your 3-point circle. So basically, let's suppose I have a reference point here and I do have a reference point here. And the next reference point with like defining the dia, I can give it here, right? So in that way, define the first point, second point, and the third point you can define. Next, you have rectangle creation. So 2-point rectangle, that is start and end point, you can, where you can specify length and breadth. And in order to modify any of these dimensions, you can make use of this dimension tool and just change it to whatever required dimension. So let's suppose I change it to 15. Right, then next we have 3-point rectangle. That is, you can give first point, second point, length and breadth you can specify, and also what should be the third point you can specify. Next you have tangent line. So you can create tangent line from here to here, or any tangent line you wish to create, you can use this tangent line tool. Next you have the creation of an ellipse. Okay, so just specify what should be the length here and inner, right? So this is how you can create your ellipse. Next you have for the creation of spline. So wherever you don't want to have a uniform line, you can go using and spline so that you can have a curve coming up, right? So in order to modify the existing curve, basically you can go to your select, okay, and you can see these are your control points. So all these control points you can move and you can play with your curve, right? So you are able to play with your curve. And then next you have is your tangent arc. So in order to create a tangent arc, let's suppose you have this line and this line. Okay. So for go with the selection of tangent arc, and you can create your tangent here. You also have 3 point arc, which you can specify first and second, and what should be the radius. So even using radius, you can create your arc. Next you have is sweep arc. So basically, uh, you can consider this as your center. Select your sweep arc, and it will give you a reference of a circle over which, at certain angle, whichever you want, you can create an arc. Okay, so next, you also have polygon creation. So how many sides you want, you can keep it, and dia how much you want to have it, that you can specify. You also can place points. So basically, when we work on beam creations or coordinates, so when we play with it, we need points, right? So in that case, make use of this points. Also, you can work with create rounded corners. So wherever you have in this condition, you can create the rounded curve. So now here random radius I have specified, but you can specify same or varying, whatever is your radius to different corners you can specify. You also have your offset curve. So you can create offset of the existing line or curve. Okay, so next you have is your trim away. So basically wherever you have a cross path, you can say, right? So this will split out into different selections. So wherever you want to cut down, you slice down, then you just select and you remove it. Okay, so this is how you can trim away. And this is to blend your straight lines. Like you have this straight line and you want to blend it at certain angle, so you can blend it, right? So this was few tools that we can use it in order to create. Let's get started with something, sketching with convert taking it to some 2D thing to 3D. So we'll start with one small workshop, which I hope you would have already addressed this kind of tool usage. So we'll try to create some pressure head. So for that, basically, we need to start initially with taking an ellipse. Let's say it's at the center and it's 100. And then what exactly I'll try to do is, before that, let me show you how to convert your geometry into 3D, so that we'll be moving on to our workshop then. Okay, so this is your all 2D and line that you have created. In order to convert them into 3D, you just have to select the surfaces and you get to see an arrow. So along with that arrow, you will see like how much should be the thickness you want to add. So let's say I have 10. So 10 is the 10 mm I have provided the thickness for this one, right? So basically pull tool is nothing but your extrude tool so far that you have used, and pull tool is only option for you available that will help you out in adding third dimension. So let it be creation of your sweep, or let it be for the creation of some revolve, right? So let's try to understand the pull tool first. So in that case, let me just first take other simple geometry creation, and then we'll move on with the ellipse one. Okay, so let's say I have a rectangle and I want to modify the dimension. Okay, so I'll just make this one 20 and this one 80. Okay, so anytime you wish to make it to your screen, just go to your home and click their home button, and we'll try to pull it. So then we'll once again our pull, we can click and we can activate and give the depth. Let's say I give it 5. Okay, now to this one I want to make certain holes to be added in both the sides. So I'll select the surface, go to design and get back to sketch mode. Okay, so in that condition, let me say I want to create it here of n, and also here of 10. Fine. So we have come back to our 3D zone. In case you want to slice it off directly, you can just move it in the opposite direction to slice it, or to add material in the arrow direction. If you pull, you will be able to add the geometry, right? So let's uh, you can do it in this way, or you can move it once again to the same way, and we'll just have one more circle here of something 8, here also of 8, and let's come back to our solid mode. So basically whenever I'm there in my sketch mode, in your mini mac, like you have your quick toolbar, so you can use this solid, return to 3D mode so that you can be out of your sketching. Then select your surfaces, like these two surfaces you want to select, or you can first slice down these two either one by one, or do it together selecting in the same direction. If it is there, you can do it at once. Okay, and you can wish to add it. Okay, so after adding this, you can also using the same pull toolbar, you can give some round feature or some chamfer to your geometry, or if you wish to play with your edges, you can also play with your edges. So let's see first, let me select these two. Okay, these two edges I have selected, and another toolbar get activated for me, which has got round, chamfer, and then edge extrude, and also I can copy those edges and also play with the pivot edge. So let me first go and give a round here. So towards arrow direction, I'm trying to add and say 1. Okay, same thing to both the edges. I'll try to give, let's say, zero point 0.5. Okay, and here this is done. And in case I want to create some wall here, so I don't have to take plane or something, directly I can select this edge and go with edge, like extrude edge, so that I'll try to get an edge here. Okay, and now in case of adding some thickness, either on this side or this side, I need to know uh, which side I want to add it, right? So if I want to add it towards opposite to the arrow direction, then I'll click on this plus symbol and move it this side. Okay, and in between these two, if I have to provide support, then Basically I'll need a plane at the center now. Now anywhere I select the surface, I can create the planes here by selecting the surface and creating a plane. So either I can select anywhere and create anywhere that I want, or if I want at the center, then I'll select both the sides and go and click on plane, so it's coming at the center. Now playing with the planes, we'll see how to play with that as well. And I'll take it to sketch mode. Now my plane is selected. Getting back to sketch mode. Okay. So if I have to provide some rib, so basically I can take some, either rectangle you take it and you draw this and you can trim it off, or play with the lines and try to get create such thing. So now since your surface is selected here, you can equally give the third dimension here. So for that you can make use of pull both side and just say to pull it both sides. So what should be the total pull you can define, and any modification you want to have here, just pull it. So that's why we say that whenever you are trying to work with the space claim, anywhere you want to modify, just select the surface, select the edges, and select all those, and you will be able to create it. And let's say I want to modify this surface as well. Like it was, I have given zero point 0.5. So let me add it another zero point 0.5 or 1. I am done adding. And in case I wish to have some chamfer to my geometry, or if I want to reduce anytime, I have reduced it here. And to give chamfer, I can select chamfer from here and give it in this way. So I hope till here you would have understood. Simple, like in the same geometry, I have used too many tools to show you how to work with simple tools, right? So a pull, almost like we have covered using round chamfer and then playing with the edges. Playing with edges is most important because anytime you are trying to modify your geometry, this can give you the reference very easily rather than taking planes and struggling to get your geometry modified. And then if you wish, you can also have a pivot. Let's say I want to make some modification like this. So you can see your geometry is modified, and in suppose the surface you want to make it touch, select the internal surface and say up to select surface. So now this is modified, right? So whatever is the new or few changes that you are doing, you just make sure you are doing with the correct dimensions you have and try to play with that. So I won't say that this is very suitable in terms of dealing with complex geometry. But yes, if you have good experience working with the space claim, you can do that as well. But mostly, space claim people use in terms of modifying the existing geometry. So there, how these same tools can be used to modify. Next, you can uh, we'll move on to our workshop, which we have just drawn the ellipse. And then so this is one of the workshop, like simple tools that we have used. You can make use of it and try to understand how to work with the sketching. And let's begin with another tool in your pull. So your pull, as I told you, you can also work on working with your revolve tool, right? So we'll start with that. This is our ellipse, and I'll need an offset for this one. So let's say I have a 2 at the offset, and I need to, for making it revolve, basically I need a quarter portion of it. So I'll divide this into 4 quarters now. So all our 4 quarters are ready, and all non-required things will select and will delete it. Okay, so let's start with first take an ellipse, divide this into four, then give an offset or first delete it off, anything you can do, and give an offset of 2. And still here, these are extra lines which I don't need. I just need a curve here. Okay, and basically you will see there will be a continuity as well here. So either you take rectangle or you take line from here and give, uh, it should be 2. So make use of rectangle or direct lines, you make use of it. So my geometry for making it revolve is ready. So basically let me consider, to start with pull, I'll go with pull and say to revolve. Okay, so for that, basically first revolve will be done around an axis. So axis is selected, then you need to select the edge or the surface you want to have a complete 360 degrees or at certain angle. You can take it, or you can give some reference as well. So to have a full round, you can give full pull. Okay, so full pull you have done and you have got this, or else you can do it manually. So when you tilt your geometry, you will be able to see at certain angle you want to create, you're able to create, right? Or you can just simply say full pull. Okay, so now with this, mostly whatever tools I am explaining you, it's not only about creating your geometry. It's always like when you want to modify your existing geometry, same tools are going to be used. So basically, whenever you're working for your geometry, you would have seen that you will be splitting your geometry into two or splitting your surfaces. So all those things we are going to carry here. So let me consider this as a surface. Okay, so this surface I'll take for a reference of creating some knob there. So let me, and here also you have options like, to zoom from here, it's always difficult to zoom, taking all the time zoom and then doing, rather you can go for control minus and control plus. Okay, and if you want to pan your geometry, make use of pan tool from here. And to spin, you can directly spin, you can enable this one, or you have your middle mouse button to spin it. Okay, so we have taken this surface for reference and we are going into sketching mode. So basically we are not creating here all the time planes, but directly we are taking the surface as reference to sketch it. Come back to solid mode. Now when you come back to solid mode, your geometry is here. So to create some, um, okay, so now if I do it in the opposite direction, basically I'm able to create this geometry because it was positive direction, right? So you can make use of, remove this no merge. So no merge basically comes out when you don't want to, whenever you're designing two solids, you don't want them to have in a single component. So you can make use of no merge, which last time we have done. And when you say plus, directly, same geometry, it's going to be a part of it and it's going to create. Okay. So when directly, if you do, you will get opposite to the direction, it's going to create a hole. So to have a addition, then go with add. Okay, so we have created this, and for the modification of all this, you can always make move. Now, in case you don't want this internal one to be available, because we cannot take a surface as a reference and to create this one. So we are taking this surface as this surface reference, and we have created. But the unnecessary one, we have to split it out. So for that, you can go to your design and you have split body. Okay. So go to split body, select your geometry, and you can give a plane reference or a surface reference to slice the geometry. So this surface I'm giving as a reference, and now I have one solid here and the other solid is here. So the internal solid, if I don't need, I'll just delete it off. Now, if you want this to be an hollow one, just once again go back to your sketch mode. So just select and you need to delete. Then afterwards you need to exit from the tool that you're using, select the surface and get back to sketch mode, plan view, into zoom, control plus, and start designing. Okay, so we'll come back to the solid mode now and we'll try to remove it. Okay, so when you set like that, you are able to get an hollow here, right? So in this way you can create, and for this kind of geometries, uh, you mostly give a round feature. So just try to give a round here and round feature here, right? So I hope this was a very simple thing that we have considered. In case still here, if you have any doubt, please let me know. And I'm always open whenever the session is going on. We can go for the questions, or at the end of the session, we can go for the session, other questions. Okay, so this is for the creation of round. Then we'll take one more small creation of spline, which basically whenever we are working for any like a CFD problem or anything, we do have to create the round like sweep geometry sweep, right? So just I'll take some spline here and select and modify. Okay, and come back to 3D mode. So now you will see in this, like I'll be picking out a point here. You're able to see the arrow and then click on this plane creation. So basically you will be able to create a plane at the point now and come back to your sketch mode. So when you say sketch mode, you can see a detailing here. So there is a shading, you can find it here. See, there is a shading available here, which you can use it for start point of yours. So this is going to be the center of your geometry. That reference is here. Okay, so I'll just zoom out. So you can see here, this is the center point. Select and I'll go back to sketch mode. Okay, and then go back to solid mode. So our profile is ready and also path is ready. So in that case, I'll just select this profile and go with sweep, select the trajectory. So you can either drag manually or you can say full pull. So that complete you are going to get, right? Without an breakage, right? So in this way, you will be able to create your geometry using spline. So there are few more tools that you can basically use. One of more important, I can say you, is your project tool. So let me just show you that. Let's suppose I have some cylindrical object here, component, and over that I want to sketch something. So in that condition, basically to place a plane here, it's a bit difficult. You cannot have it at wherever you want. So in that case, I'll just prefer taking a center line from here and creating plane there. Or I could prefer to select either one of the axes from here, any axis you select, come out of your tools, select one of the axes. So for me, x axis I have selected and click on plane. So I'll get a plane in YZ axis. Similar way, if I select my Z and I want a plane in XY. So XYZ, XY, I'm able to create a plane, right? So if I need a plane in X and Z, then I'll select Y and say plane creation, right? So once this plane is created, I can just move this plane using move tool at certain distance. Okay, and now I can make use of this plane to project something over that cylindrical object. So I have a reference, like this is my boundary of the geometry, which I should not cross it. Okay, and come back to the solid mode. Now this I can project it on the solid body, and you can see the preview and say okay. So this is how you are able to create some projections, and basically to give some imprint or to create something on cylindrical surface, it's difficult. So there, how just use the project tool and you can create it. Or even the same, you can use it instead of giving project, just select the surface and give up to this surface. So you will be able to create a T joint, right? T section. So, and anything till here you have to discuss, do let me know, or else after this we are going for some cleanup things that we can carry out.
Yes, any question from the participants?
Also, you can let me know
Uh,
if I'm going fast, slow, whatever is your opinion, so that I can modify it according to your way.
I hope the speed we are okay with the space and speed evaluation. We're going fine.
Okay. So we'll begin with now just a glimpse I have given in terms of working with the SpaceClaim. So there are so many tools are available that you can check out, like split you have, which you can use to split your surface, right? So in this way you are able to split your surfaces. So mostly whenever when we are going for our further workshops, you will understand, like in terms of applying some boundary conditions, how splitting of geometry is important. So there we can use this split tool to split your geometry, and you can create shell geometry by con- uh, you can create shell using shell. You have mirror to create the mirror object of your existing geometry. Okay, so then there are few more things which in the same go I cannot tell, but I can tell you that you can go with the Ansys help here, which will help you out in understanding each and every tool existing in further anywhere you want to just work with the SpaceClaim. Okay, so you have here SpaceClaim, each and everything like selecting operation, whatever is existing, all that will be there. So in terms of selecting, how you can use different selections, and let's say you want to go with the selection, so how, what are the selections are available. And apart from that, if you say you want to do some pull operation that you have seen right now what we have done, so just go with designing pull tool, and each and everything you will be able to see, right? So there are different various options available which you can use it to understand when and where you can use this tool. And also there are lot of tutorials are existing which can help you in terms of understanding the space claim. But the main agenda for us is to work focus on the simulation part. So we'll just move on with the uh, geometry cleanup and preparation one. So let me just open one of our geometry. Okay, so this is one of the geometry you can see here. Now, looking at the geometry, you would have definitely noticed that there are certain changes that has happened to your geometry. So, other than that, you can also look at your tree structure, where you can see, you get to see a complete surface bodies are existing here separate. So and the other are solids. So now out of looking at this you can understand that yes, there is some data loss that has happened. So just take 2 minutes of time and come up with your things like what can be done to overcome this geometry whatever issues that we are getting. I want everyone to speak up. If anyone has already worked, they can tell me, or the freshers can also try what should be done. So I think there is no answer. Either people are listening or people are not at all listening. Okay, so in order to have
Just a minute.
the complete, yes, yes, is someone saying something?
Using this software, the test analysis can be carried out now.
Sorry, I'm not able to understand what you're saying. Could you please drop it in the chat so that I can read it out? Okay, so basically by now you have seen that there are surface body conversions taken, right? So those things have to be repaired. So to repair all anything related to solidification issue, you have stitch gap and missing faces. So these three tools are capable of converting your surface geometries into solid if there is some data loss taking place. So in that case, let's say a stitch where it can be used. So you can uh, like you can say there are two surfaces which are near to each other and they are not connected, so you can use them to convert them into single surface, right? So there you can stitch those two surfaces together. Gaps are there where between the surface edges, near to surface edges, if you see gaps, so there a tolerance value you can specify within which range it should find out, and you can figure out the gaps and you can try to remove those gap issues. Then next you have is the missing faces. So basically for your missing faces, it's showing you two three things that yes, there are certain missing red indications you are able to see, right? So those you can use it for your like looking at like yes, there is some kind of missing faces. So let's first start with the stitch of your geometry, because first when I checked here it was showing there is something needs to be connected. So let's click on this. So you have a green check for completing that operation, and checks with the gaps, there is no gap it is showing. Missing faces, it's showing one missing face now. Earlier it was showing two, but now one. So let's click on this green check and convert it into a solid. Now the solidification issue is cleared out, right? So what could be the other issues? We have to find it out. Now look at this geometry. If you look at it, you are able to see that there is some kind of misalignment between the components has happened, right? So basically you should know that whenever you are importing some geometry here, you will have single component with single color. So there is some kind of different difference in the appearance itself. You can say that there is something wrong. So to rectify this kind of issues, you need to use your interference tool. So this interference tool will let you know where is the interference issue coming up. So basically you can solve this issue using two ways. So one of the way is to measure how much is the interference here, and you can say here this is the start and this is the end one, right? So this, what is the distance, you need to find out and use move tool to move it, or you can go with the assembly tool and align those two properly. So let's first start with measuring and say first from where it is starting the interference and the next one, and click on measure. So it is showing there is a interference of 9 mm, right? So now 9 mm you have seen. Come back to, now we'll just zoom out. So next, either this complete geometry you move it in negative x-axis 9 mm, or these two or internal components. So it's better that we move it out one.
Hello. I think your screen is not visible.
Uh,
Hello.
I'll reshare it.
Okay, okay.
Yeah, now is it visible?
Yes, yes.
Okay. So do you want me to repeat something that you have missed out on the screen?
Yes, students, you should repeat or continue.
You can
Okay,
continue.
I think you can continue.
Yeah, we can
Okay.
continue,
So
Sangeeta.
yeah. So basically, as I told you, in order to solidify your geometry, you can just use your stitch to stitch out whatever two surfaces they are not connected. Connect them, gaps to find out wherever there are gaps, and missing faces to find out wherever there is a surface missing. So with this, we are converted our surface geometry to a solid, perfect solid. So in that case, next would be to look at this interference that I was telling you, right? So this interference we can rectify it by going to measure and first measuring the start and the end one. So you need to find out right. So after measuring these two, 9 mm of interference here, just go with the r- repair tab. If someone is asking for the control, please don't ask for the control. I don't see my tools here. Okay, so now you can see here that there is a 9 mm of interference here, right? So let's go with the prepare, and directly we cannot remove it using interference tool because it was in between, it will slice off the geometry, so it doesn't make sense anyways. So we'll go with design and move our geometry. So either that geometry or here we can move it in 9 mm in the negative x-axis. So this is how now we have removed this interference, and you can check if there is some interference existing. So now there is no interference. And the other way is like whenever you are working with the cleanup kind of things, no, you don't see that in a single method. Sometimes your geometry, depending on your geometry, your issue can have different procedures to solve them out. So the other one is to work out with your assembly one. So go with assembly, and before that we'll have to come to some section view. Okay, so go to section view, and when you go there, you can create the section view from here and click on plan view. And now here, if you look at it, you can see there is some disturbance in the flow of hatching, right? So here itself, you will understand, yes, there is a problem. But when you look at the other portions, it's clear, right? So even in this way, you can like resolve the issue. So we'll go with the assembly, align this and this. So when I move first one this, so this towards this direction it has moved, and here it has created issue. So I'll first move this one. Before that, coming out of tool, okay, now we have seen the alignment is done, right? So coming back to solid. Now also you can see the issue is resolved. So in this way, basically you can resolve your interference issues. These are the two ways, or you can also like assemble your geometry once again. So what could be the other problems that you face in terms of clearing your geometry issues? You have other options, as I told you. In your repair, you can also check for extra edges, right? So like whenever you're importing some geometry, if some extra edges have been created, you can see the indications will be showing here. So let's get on that portion and try to see where are these issues. Let me check extra edges. Still, I'm not able to find it. So in that condition, I'll hide this one. Okay, so now let's check. So here are the two extra edges that are existing. So basically, uh, having extra edges and all will create some problems when you're trying to measure geometry. So those things have to be rectified when you take it to your cleanup. And now, if any of these are not of your interest, like you would have created for applying some boundary condition and still it is detecting under extra edges. So you can remove those. Select those, use this exclude problem and select that. It will turn to green. That means you are giving permission to be available. And the other one, it will remove out. Okay. So, I mean, like for based on your requirement, you can change those. Then next, you can also check for small faces. Now, when some intricate geometries are created, there will be lot of surface creations, not only because of GUI change, but also because of creation geometry, the way it is being created. A lot of surfaces, small surfaces tend to get created. So those you can remove it, and you can avoid element quality criteria. When you don't achieve those issues, you can avoid it. Then to merge two faces, you can use this merge faces. Somewhere I'll try to show it to you. Let's say I have a split of surface here. Okay, so these are the different surfaces. So to merge them out, you can make use of repair, merge faces, this and this if I want to merge. So it will merge it. Or if I say this and this to merge, it will merge it, right? So you can merge your different surfaces into two or more or into single as well. Then in order to remove some round, let's say here or somewhere we have created the rounds, right? So to create remove that, you can use this remove round short edges. Not only when your single edge gets splitted into two or more edges, so there are small edges existing, you can remove those. And in order to create some welded connections, you can make a use of spot weld or weld condition from here. Okay, so let me take you to other simple one more example. Now if you look at these geometry, this is consisting of like bottom portion. If you see, these are uniform cross sections, right? These cross sections have like proper uh, thickness is same, right? Maybe different layers have different thickness, but they for particular component they have a proper thickness. So in that kind, wherever you have uniform cross thickness continued, you can convert them into 2D and you can solve your problem. So let's say I want to convert all these into surface bodies and I want to solve my problems only just for the bottom section I'm talking. Okay. So let me just get into some, okay. Oh, okay. So one of the view, I take it and I make use of box selection and say height. So this is my base plate. Now when I look at my geometry, I get to see there are certain imprints existing. So if these imprints are existing, it will create some problem for me in terms of surface body creation, because we spoke of having a uniform cross section throughout. So for that reason, first we'll set our view and select the only imprint you can select, or you can select the complete flat surface where the imprint is done and say delete. So that is gone, right? Next important things, there are small holes existing. Now when we work on simplification of your geometry, like you can have a complete assembly, but when you want to solve it for just a component, you need not need all the other components with you. So we'll remove all the other components and all unnecessary things and we'll try to solve. So in case of me solving this problem, if the small holes are not playing a vital role, I'll just remove those. So for that, I'll do one thing, that picking one by one is little difficult. So I'll just go with some selection option here. And before that, I'll just go with repair and go with stitch or some. Okay, so let's just directly convert it. Okay, so now I can go with the selection directly. Select these two surfaces. Okay, and go with selection criteria, equal radius cylinder, so that all the cylinders are selected here. You can see here, right? So all these are selected. Click on delete. When you don't need all of this, you can remove them easily. Then next you have is to convert all these into 2D bodies. So we have repair once again, and then prepare. Out of that, we can make use of mid surface extractions. So one by one you can try to do, but make sure you're not missing out these 3D bodies. So just check that and do. And I'm trying to do it at once. I'm selecting all these geometries, and two different color indications is for when it is trying to take the mid surface of that. It is just an reference for it. So I'll just say okay. and anywhere on the open space you click, and you have converted your 3D geometry into 2D one, right? So let me go back to my surface, complete geometry, and uh, I'll just check on this one. So that other conversions what are required, I'll show you. So in case of 1D conversion to do, you have extract from your prepare tab. Just go and extract those. I hope it's visible to you all. Okay, so you are converting this into beams. Right now, uh, I'm trying to do everywhere so that few more what all different things I get to see, I can share it to you all when you're trying to work. Now, when you look at this portion, you can see that there is no continuity here, right? So this continuity, you need to manage it by uh, mix, like trying to extend these two. Okay. So for that, basically, you can zoom and you have tool here. Select this edge. Now curve one, if you do, then curve extension will create it. Big X will create it. So you need to take a flat line, whichever it is there, and go with up to and select this one. So that you are able to convert it. Same way, here you can do extend, like up to you can use, and this is extended. So in this way, you have to extend all this. Here directly you can also make use of uh, extend tool, which you can see whatever are the extents that are it is showing. So if it is having an extra extension, that it will show, or if it is having some like gap is existing, that within your distance that you have specified, it will try to get. Okay, so extend, you can make use of it. So I hope you have seen the conversion, and also you have seen how to work with 2D and 1D conversions. So next, let's move on to the next topic of ours today. Okay, so basically when we talk about understanding the any problem that we are trying to deal, designing, I'm assuming that a bit I have given you a glimpse. Next step would be to give you an understanding of how you can get started with your simulation. So what are the different things you will be getting through? So first is like whatever problem you are trying to solve, you need to know the basic set of equations that are going to be solved, so that input values you will be able to give, right? Then you also need to have some geometry with you, some material that you are adding, or working on the mesh, working with more than single component. You need to give load transfer, how it should take place. So connections come into action. And after that, for solving any problem, what is the duration of the time that you want to solve for? Let's say I am solving a linear static problem. So it will be for 1 second. And if you want to solve it for steady state, what are the time steps you have to give, or what type of solver you have to use, what are the output controls you want to have, all those you can specify in your analysis settings. Loading condition comes up for defining the loads and supports, and how to display those loads and support you can you will be checking. And what is the major difference between working with contact and supports? What exactly like we always keep whenever you see any video, or if you have worked on it, you will say we are working with contact, we are working with support. So what exactly that means, and what are different solving modules, and how to get with the results and post processing. So before that, let's have an idea like how exactly an simulation procedure works for us. So first, as I told you, is the problem identification stage, where you will try to identify based on your output what results you are looking for. Let's say I'm looking for an what is the deformation taking place in my geometry. So for that I need to go for static analysis. And if I'm interested in getting to know the thermal temperature distribution, I have to prefer the thermal one, right? And the other thing that comes out is like when I'm trying to solve my geometry, what kind of simplification I can use it so that my solution get done faster, and I'm doing it in a smart way. So like wherever you it is possible, you can take the consideration of converting your 3D geometries to 2D and 1D. And also you can what to say, you can convert it into certain symmetry condition or cyclic symmetry condition. So any of those assumptions you can make use, and you can try to get your solution faster, right? Then you proceed to your pre-processing stage, where you need to have your geometry, and you need to work on your mesh, define some boundary condition, and also get the results for that. And after that, you need to check for the post processing. So these all things comes up. So let's take a small example where we'll try to work with the flow, which will let us know what would be the flow for our next working. Okay, so let me open Workbench. So whichever version you have, you can open it. Okay, so this is your Workbench where you have different analysis systems, predefined analysis systems are existing. Like you say, for performing any problem, let me consider I am working with a structural one. So material, if I want to define engineering data is there. Then to create geometry or import geometry, I can click on it and work with further meshing connections and doing the setup and solution what I'm looking for, and I can go for post processing. So already a predefined thing is existing, so I can use that, or I can directly work only on engineering, only on geometry, or only working with the mesh. So for mesh I need a geometry, so the same geometry thing I'm using from here, and then I link it to my uh, like mesh thing from here. Okay, so all this you can couple them together and you can have it. So let's proceed with having one simple geometry. Okay, so I'll just create it here itself. So let's say I have a beam cross section that you have seen in the presentation. Okay, so 50 by 50, I'll consider the cross section here. So I'll just make it 50. And here also 50. Okay, then come back to solid mode and define what should be the length. So it is 1000. Okay, so this geometry is created. I save it somewhere. Okay, and then I come back to my workbench and import the same geometry from here. So that was my recent one, so it's available, and I'll open my mechanical window. Also, when you are trying to start working, no, check with your units what is the set of units being used. Okay, so this is your geometry, and whenever you see question mark, then there is some issue with your geometry. First, you need to check your geometry. Then default material we are using here Then you have coordinate system. When we are moving further for the session, you will understand how to work with the coordinates. And you have here mesh. So we'll go with the default mesh generation now, and the working with the mesh things we'll discuss tomorrow. And next we have static and insert. So when I say insert, I, as per my problem, like if you look at my presentation, there was a cantilever beam condition. So in that one side was fixed and the other side it was experiencing some load. So I have vertex selection, edge selection, surface, and also body selection. So I'll go with the surface selection and insert in say fixed support. Then next I have in the opposite side, I'll just take a edge selection here and say insert and force. Okay, so now in this condition, you can look at the global axis. So to have a downward loading, I need to give in the negative y direction. So I'll change from vector to component, and in the negative y direction, I'll apply some load here. Okay, so you can see the arrow direction, and for my results I can check for either total deformation, or I can check for directional or some stress calculations if I have to do. So this process enables you to know from the tree like what all different things you are going to work on. So mesh you need to work defining boundary conditions, getting the solution, but when you move on to more than single component, you have to also work on your connection part, and you need to add by default material we have used, you need to work on defining a material as well, right? So you can click on this and try to see the results, and there are results. So you can see the actual deformation, how it is taking place, and stress where it is generating. So basically all these things, when you uh, look at it, by now you would have understood like yes, this is the standard procedure that we are discussing, right? So the same thing you have seen in your uh, presentation here. Okay, so let's proceed further. Like now we have seen how to launch your linear static analysis. Then let's understand what is the like what is the basic linear problem when you're trying to solve, when exactly you have to like what is the actual value that you have to give as an input. So when you look at this equation, kx equals to f, now you have k as your stiffness matrix and x is nothing but your displacement vector, but as input f is the load factor. So basically for performing a static one, will um, will have to give a force loading, right? So this we have given a loading condition, and since this is a linear problem, we are not considering any time varying factor or some damping effect. Nothing is there. So when you proceed further for the other non-linear conditions, you will have to consider those also, depending on your problem statement. Okay, till here, any questions? Do let me know.
Yeah, anyone has any question, please you can ask. Uh, you can proceed. I hope there isn't any question.
Yeah, sir, can you let me know what is the lecture timing and when is the practice art session
Uh,
starting for them?
yeah, we can. This means like overall session timing we have is 3 hours. So if you can start whenever you wish to in between the practice session.
Okay, fine. So basically, we'll proceed for other things tomorrow, but I'll proceed with giving you a glimpse about meshing today so that you have an idea of working with the mesh thing. Okay, so let us understand what are the fundamentals of working with the mesh. So, is anyone having any idea working with the mesh? Please let me know. I prefer if someone speaks out because it becomes really kind of boring kind of session if no one asks questions or no one answers anything, because it's always a one-way communication going on.
Yeah, everyone, please, if you know any basics of meshing, you can please, or if you have any question, you can ask.
Well, meshing is a fundamental type of finite element method in which we divide a system in some parts and elements, like in analysis in finite element analysis.
Okay. So
Ma'am,
basically,
ma-
yeah,
meshing
please.
is generally made up of element and contains nodes by which we coordinate with location in space, and it may be vary with element type.
Okay, great. At least you people answered, so happy with that. So basically, let's understand like where what exactly means by meshing. You would have studied in your finite element method subject, right? That you are trying to work with the nodes. You are trying to get the displacement x1, xyz values, all that, right? So exactly the same thing here. You know, that same equations or are going to be considered here for solving your problem. You have seen the equation already, right? So in this condition, what exactly happens is when you apply a load on any of the surface. Right now we have applied a load at the edge, right? How that load transfer takes place, the like for the software to understand, it's always about solving a set of equations, right? So that's how the geometry will be split out into small small pieces, you could say, and those pieces are nothing but your elements, and those elements are made up of some node to node connectivity. You can see the first figure and the second figure how these elements are done, right? So you basically you can say it's nothing but your discretization of your geometry into small small cells, and that you say that your geometry is meshed. Okay, so when you know that, it is going to help you out in terms of load distribution and getting the results properly. So there are certain criteria that you need to measure geometry properly, so it's coming under mesh quality perfectly. So for that, what exactly we need to do to get the proper mesh quality? You have to understand uh, different methods what can be used to for different types of geometries, what are local controls, what are global controls, and out of that how to get your mesh quality, right? So that's how we have to work for the mesh. So let me say, uh, now we are working on different physics, right? It can be working with CFT or working with mechanical or someone from electromagnetics. So for them, physics is changing, equation is changing, everything is changing. So we need to define what is the preference of physics. Physics preference will give it. Then next, based on the method what you have selected, we there are different like elements. Two types of elements are there. Basically, you can say either tet or hex. You say based on that there are categorization of methods. So first, coming up with the tet, you have patch confirming and patch independent. And for hex elements, you do have multi-zone and hex dominant and sweep you have. So for all these, you can work on mesh for 3D, and also you have a automated mesh which we have seen last time. Then for 2D geometry, you have automated method, you have triangles, and you have uniform quad triangles, right? So let me just take walk you through one of the small example I can tell you with the same geometry. Let me remove all the other things here, or else I could take some other geometry. Okay, so same method that we have used so far. We are going to just open a step file, STP file from here, and just open. Okay, so first when I imported the geometry, I am able to see two question marks. So that is because thickness is not specified. Let me just give me a random thickness for these two as of now. Let's say I give it 10. Okay, so I give it. And for the 2D geometry, for meshing, we have seen that there are a set of methods, right? You can go with the automated one, you can go only with the triangles, or you can go with uniform quad and triangles, or you can say you just want to have just the quad view. Okay, so let's go with it. And first, I'll suggest whenever possible, first go with the automated method so that it will at least give you an idea that yes, what component is suitable to go with for the component. Okay, so basically you can see here, this is your mesh, right? So just go with the quality section once and go and say element quality. Now we say that when most of your elements are coming within a range of zero point 0.7 to 1 range, you have good elements coming up. Now if you look at here, few elements are there which are a bit of poor quality, right? So basically you can do one thing, that is give a sizing control for this, right? So select both the surfaces and click and apply here. So you are giving us geometry selection option here, and default element size it is considering 7. Let's make it as 4 or 5. So let me make it as 5 and say to update or generate. So whenever you're trying to work with the mesh, it's always about you looking at your element quality and then improving, because it will give you an idea where exactly you have to work on your mesh, right? So you can see here 4 doesn't work out for us, so we need to go with something less. So this just to show you other advanced techniques. We'll check it out. Right, so how much ever you do, it's not ready to improve its quality near to the edges, right? So what you can do is just go here, select the edge and say create name selection based on size and say okay. Now you give another sizing control here and change your selection method to name selection, and the name was selection, right? So give it here and give 0.5 as the element size to be aligned here, and just say update. So now basically under your selection, you can see 12 edges are selected mostly. So just go and check here. Now when you say point, when single elements were created, all this we have changed to have and zero point 0.5 of 5 elements getting assigned. So basically these are few techniques which we can use. So and always here also it has created, so you can make use of name selection anytime for figuring out this kind of issues. And as of now, when you look at your geometry here, 0.7 to 1, if your maximum elements are coming up, that is quite acceptable one. But in case you want to proceed further to have good quality of elements, then definitely you have to struggle a lot, and you have to work with the different local controls and all whatever are existing. Okay, so most of our issue with the edges is resolved. So few more techniques we'll see in the further when we are proceeding. So let's understand what else can be done. So let me just take another example for you in case of dealing with 3D problem. Uh, okay, these are all geometries that I have here.
Yeah, Sangeeta, sorry to
Yes.
interrupt in between. There
Uh,
is some question in the chat box, if you can see it,
okay.
regarding the meshing.
Okay, one person has given how to work, what is meshing answer, and the other one is how to find the appropriate size of meshing. So basically, there is no appropriate size like what you have to take. Always you should make sure, let's use suppose you are working on a 3D 3D geometry. So you can say that you should avoid having single element across your thickness, right? So when I'm opening my next geometry, you will get to understand that. I'll take some good example that tomorrow also we can
And
use it.
so, to add on how to find the appropriate size of meshing, it totally depends upon your geometry part. So for that, in finite element, there is one very common term we usually uses convergence. So you need to converge your meshing first. Okay, based upon the solution, you converge your meshing because unnecessary dealing with a high number of elements will end up very high computational cost. It will take a lot of time for you to analyze that problem. And whereas if you take a very less number of elements, then you are sacrificing with the solution. So your solution will not be accurate. So in that case, what you have to do is you have to slowly increase the number of elements in your particular geometry. Based on it, you need to check your results. If your results are converging at that particular meshing size, at that particular moment only you can say that yes, this is my appropriate size for that particular geometry. For each geometry, for different size of geometry, your meshing size will change. So we cannot say what is the appropriate size for any particular geometry as such, infinite element.
Okay, so I
Yes,
hope we
Sangeeta,
can
you can
proceed.
continue, please.
Yeah.
So I think as of now, I have given a glimpse of getting started with meshing. So I would request everyone that when you start with your geometry creation, then you have cleanup of your geometry. I'll be sharing you out the geometry, and then one 2D geometry I'll share it to you. Just try to do a bit of homework in your working hour itself, that how you can work on your mesh. So anyways, in the further session, we'll be covering about the different methods that are coming up, different like techniques you can use, or you can say smart way of working, you can best practices will try to share with you. Meanwhile, I'll request everyone to just come up with certain idea about working on mesh. Yeah. Gulab sir, we can align students for working workshops now. They can sit and practice.
Yeah, most of them, it's there is they would have installed the student version, or there's a lab where Ansys is installed. They can work on that, right? So we can proceed with. Uh, so you'll be giving some geometry
Sangeeta,
along
can
with.
you please,
Uh,
Sangeeta, can you share those geometries with Gulab sir
Gulab
so
sir,
that he
please share
can
me your
forward it
mail
to
ID.
all the all?
Ah, o- okay. So do I need to send them through mail?
Not necessary. I'll give you a link. From there, students can directly download. I'll put it in the chat
Yeah. Okay.
itself.
Yeah,
Navita,
that would be
put it
better.
put
Yeah,
it in the
because
chat box so that everyone can access it through Teams itself.
Yes, yes.
yeah, that would be
Just
better.
allow me
Yes,
some time. I'm working on it.
sure.
Meanwhile, you share the geometry on Teams itself so that those who are there they can start opening at least.
Tushar, I don't think I'm able to do it in the Teams. Yeah, I need to share the link itself. Please hold on for a while. Yeah, there's a link. Please click on that, and you have geometries coming up. So I'll just tell the name. There is a bracket.stp file, and you have pressure vessel.stp file. So these two basically you can use it for your meshing practice initially for 2D geometry, and you have turbocharger which you can use it for cleanup, and you have crankshaft. Same procedure you can use it and work for your workshop. So basically, 4 workshops. I'll name it in the chat itself. Uh, can someone confirm me if link is accessible?
Yes, ma'am.
Yes.
Yeah.
Yes, Nidam. So uh, you would be sharing in parallel how to they would be doing step by step, or they need to do it like how on their own.
Sangeeta, it will be good if you share the recording link also here itself.
Okay, sure. I'll do that.
Yes,
Just it has
record.
generated.
Yes, already I can see the recording.
Yes, yes. Just it got added. I'll share it.
Already I can see the yeah.
Only one request is there from everyone. Whenever I'm sharing some drive link, please do not delete any file from there. Yeah, recording link is there.
some access needs to be given to that recording link?
I don't think so. It's required, but just let me know if some such issues are coming up.
Yeah, because when I am clicking the link, it says you need to have an access.
Okay, I'll just do the needful here.
Yeah, then may please check if they can access the recording link and let us know. Participants can please confirm.
I think this one you should be able to access the second one.
Uh, no, it says saying that you don't have access to this file. Yeah, there's someone in chat box also says that they can't access it.
I tried with a different browser. It's working for me, but
Yeah, it, maybe you are the owner, that's why it's working for you.
no, I'm just having different type. I was trying to do it with a different browser so that issue doesn't come out. I shared a new link with the permissions. Just try and let me know.
As of now,
For the practice session, I would request students, whoever are working, whatever 4 workshops you have taken right now, one each student have to do it, and when they are doing, they can share their screen so that it looks a bit of effective that yes, a workshop is going on.
that's working for all. Let me know because one participant has said that it's working. Yes, so I hope it's working now.
Like as a requested, I want at least one student to do the workshop and show it to everyone here, so that who has missed out anything, at least they will also do the workshop. And anywhere you get stuck up, let me know. I'll help you out. You can share me your screen so that I can guide you wherever you're getting stuck.
Hello, ma'am. Hello.
Yeah,
Yes.
hello, Sangeeta. Yeah,
Hello, ma'am. There is
yes, you
an
can ask the
error
question.
in. Hello.
Yeah. Error in.
Ma'am, I'm getting one error in missing faces of cleanup of crankshaft section.
Okay. Can you
Yeah.
project it?
Okay. I done stitches, then gaps, then I'm getting one error in missing faces
Mm-hmm.
that found one area,
Okay.
and when I'm trying to resolve it, then it's showing that
Okay. You can
not
try.
resolved.
Try in other ways. Like first, you try to go with stitch and then try to do missing faces.
Yes, ma'am, I have done that. There is no area found. in stitch
No,
section.
not like that. Take the initial geometry. Please take initial geometry. Yeah, for cleanup of geometry, there is no thumb rule existing that only sequential flow you need to use. Can you take a fresh geometry of this sieve or undo?
Okay, ma'am.
Right. So just try
Yes.
to go with the stitch ones. Okay. Now check with the missing faces.
What about gaps?
You can do it further. Just try using either of the ways. No, when you're not able to proceed further, you have to change the step.
Okay, ma'am.
Now try to green check. Click on the green check. Yeah. Yeah. Now try to check for the gaps. Okay. Once again,
Yes.
check with the stitch.
In stitch section, there is no area found. In
Mhm.
gaps, there is no area found. But in missing faces, there is found one area again. And the same
Can you try to remove this once?
again, there is pop-up window. Could not replace faces with a single face.
Okay, I'll do one thing. I'll try to open the same geometry and try to go for it.
Okay, ma'am. Thank you.
Yeah. Okay, so let's try in some other way. You can also try vice versa. So,
Okay, ma'am.
because so meanwhile, it's taking a longer time to get it done. For solidification, when we say like these three tools are existing, so vice versa, we have to try and we have to rectify the issues here. maybe for me it is taking longer time. If someone has done, please show me your screen as well.
There's one question in the chat box. There's like, is there any manual for geometry cleanup?
Yes, we do have a manual is existing, but that will be shared out after the session so that whenever you want to review it, you just have to look at it and you'll get an idea. Yeah, meanwhile, if anyone has done faster than my system, then please show me out. Okay, and no problem. Let me just find out if I have a lower version file available with me so that I can share it with you. People, you can do one thing, like whoever is not trying able to open the R2 file, no, go to GrabCAD and from there take any random geometry and try to do the cleanup thing. Yeah, try to work out on the crankshaft. If you're not able to do it, then I'll just try to share a recorded one, something related to the crankshaft one. Because for me, it's still taking a bit of time to get it resolved because the problems that it is encountering, it's too many. In your space claim, geometry creation and repair thing, whatever uh, like document is required to understand, it's added in the chat box, and also a feedback is added. Please do fill that and let me know your valuable inputs. Sure, I'll share the file location. Yeah, link is shared. Files you can download it. Recordings are not available to download. For your reference in future, I'm sharing you out the link. You can refer that link, and also you can go through the document that I'm sharing. Okay, for the people who are still facing the issue, who haven't tried it properly, once again, just let me show first. We'll try with the gaps and try to fix this. Then checking with the stitchable possibilities and checking with the missing faces. Okay, so here you can check your solid geometry has been solid. So basically, as I told you, vice versa, you have to try and you have to get the solidification done. So I do let me know in the chat whoever has finished the solidification thing of crankshaft. And also one more announcement to do that all 5 days of feedback form is important, filling is important because ARK is going to give you an like acknowledgement that you have attended the 5 days of workshop.
Yeah, Sumita. Hello.
Yes, sir.
Yeah, madam is there.
Sangeeta, can you hear me?
Yes, now I can hear you. Please tell me.
Okay. Yeah, fine. Is there anything we have to cover today, or like a student has to practice? Like,
Yeah, it is like 1.5 hour is completely dedicated to the instructions that we are giving. And I think a 20 minutes
mhm,
extra itself, we have done it. So, and later comes up is the practice part.
mhm. Okay, fine. So, if any student has any question or something like that, or they have done it, any participant, if there's anything, let us know. Okay, what we are like, ma'am, what we are like tomorrow, as I hope the meshing we are going to cover in detail, right? That is what is
Yes,
the
sir.
plan. But,
Yes.
so, ma'am, what actually I would request is that like step by step, if we go like when we're in parallel, if we do the task like that was I was thinking, like we share with the students, and in parallel, if you perform a step, they perform a step at the same time. This is how we can go. So they would be more clear with each and every step.
Okay, we can come up with one conclusion that once I'll do and show it, when it is the participants doing time, no, I'll try to go once again with
Mhm.
the step by step so that it will help them
Yeah,
out.
that yes, that would be better. And if in that phase they face any problem while doing that work, they'll be asking the question in their query. They'll be asking the query at the same time.
Yes,
Sure, sir. We can
That would be
incorporate.
the
We can incorporate it.
yeah, yeah, sure, sure. So we can wait for 10 minutes more if the students have any query or if they are doing the cleanup stuff.
Sure, sir. Sure.
Then probably we'll wind up the session for today.
sure, sir.
Uh, yes, Sangeeta ma'am.
Yes.
I hope now if there is no query, and we can close the session for today.
Yeah. Okay. No problem, sir. We'll connect tomorrow and we'll try to do the parallel sessions
Yeah,
as you have told.
yeah.
Yeah.
So that will be doing tomorrow. Okay.
Yeah.
So, yeah. Let me see if there is
Initially,
any.
my
Yeah.
concern was
Okay.
that only. That I told
Mhm.
students to do one by one so that at least those things, whatever we have covered, they can have a glimpse, and at least with that, students will do it. So,
Yes, but yeah, but what we can do, we can move a little slow tomorrow, and
sure, sure.
you can share the file initially in the starting phase only, and when you start, so they will be doing it, and at the same time you will be doing it. So that would
Okay.
be the way we can go forward.
Yes,
Yeah.
sir, that will be great. We'll follow the
Uh,
same tomorrow.
yeah. Yeah. So if there is any question from the participant, we can take you can ask right now, or we'll be meeting tomorrow. Otherwise, I hope there isn't any. So thank you all for for your participation. We'll be seeing you tomorrow at the same time at 3 o'clock. Thank you. You can close the meeting.
Yeah, thank you so much. And I'll end up the day for today. And tomorrow we'll connect at the same time, 3 p.m. with new topic. Thank you.
Yeah, sure.